Welcome to the House That STEM Built, a regular series where we will explore the science, technology, engineering, and math that goes into the design and construction of this family home. This is the House That STEM Built.
In a previous episode of The House That STEM Built, we calculated the area of simple geometric shapes found in the construction of a family home. This included rectangles and right-angled triangles. In this episode, we will learn how to calculate the area of more complex geometric shapes by breaking them into simpler ones. This comes from the New Brunswick Grade 7 Math Curriculum Outcome SS2. Develop and apply a formula for determining the areas of triangles, parallelograms, and circles.
The areas of many common shapes can be calculated by using well-known formulas. For squares and rectangles, this formula is length multiplied by width. For right-angled triangles, the formula for calculating area is half the base multiplied by the height. Let's look at some examples where knowing how to calculate the area of more complex shapes is important in the construction of a new house.
One example is calculating the area of the floors for the various rooms in the house. This is important for determining how much flooring material, like hardwood, tile, laminate, or carpet, is needed to cover the rough flooring surfaces. In this house, the majority of the floors were finished with a vinyl plank material that resists stains, scuffs, and scratches. This is a great option for homes with children and pets. The bathrooms of the house were finished with ceramic floor tiles with electric in-floor heating beneath them. You can learn all about that in another episode of this video series on heat transfer.
Once the building contractor knows the types of flooring materials being used throughout the house, they will break the floor plan into smaller sections in order to accurately calculate the total amount of flooring materials that will be required. Let's take a look at the lower level of the house, which has a living room, games area, home theater, 2 bedrooms, a hallway, and a bathroom. All of these rooms except the bathroom were finished with vinyl plank flooring. There is also a mechanical room and a storage room. However, both of those areas have unfinished concrete floors, since they are not considered living spaces that are used regularly.
For each of the rooms with vinyl plank flooring, the building contractor needed to calculate the total area of the floor space in order to know how much of the flooring material was needed. Some of these areas, like the living room and games area, are basic rectangular shapes. However, other rooms have more complex shapes and needed to be broken into simpler components. Let's take the home theater, for example. It's basically made up of this large rectangle and this smaller rectangle. By multiplying the length and width dimensions for each rectangle, we can find the areas of each section.
For the larger rectangle that makes up most of the room, the length is 14 feet and 3 inches, and the width is 13 feet and 2 inches. Since 3 inches is 1/4 of a foot, we'll refer to the length as 14 1/4, or 14.25 feet. Similarly, since 2 inches is 1/6 of a foot, we'll refer to the width as 13 1/6, or 13.166 feet. When we multiply these dimensions together, we get 187.6 square feet of area. This represents the area of the large rectangular portion of the floor.
For the smaller rectangular space located behind the home theater screen, where the homeowners keep their pinball machine, the length is 9 feet and the width is 3 feet and 6 inches, or 3.5 feet. When we multiply these dimensions together, we get an area of 31.5 square feet.
So by adding the area of the large rectangle, which is 187.6 square feet, to the area of the small rectangle, which is 31.5 square feet, we get a total area of 219.1 square feet for the floor of the home theater room. Now the contractor knows how much flooring material will be required for this room. Flooring contractors usually add an extra 10% to what they calculate they will need, so they have extra material on hand for the job. In this case, the 219.1 square feet would be multiplied by 1.1 to represent adding an extra 10%, resulting in an area of about 241 square feet of flooring material required.
As we mentioned earlier, the flooring material used in this room is a vinyl plank material that is made to look like a natural wood surface, but that is much more durable and resistant to spills, scuffs, and scratches. Each piece of the vinyl plank material is 4 feet in length and 7¼ inches in width. Knowing these dimensions allowed the builders to figure out how many pieces were required to cover the floor of the room. How would that be determined? Pause the video here and see if you can figure this out.
Okay, let's have a look at this. If each piece of the vinyl plank material measures 4 feet in length by 7.25 inches in width, we can use the area formula for a rectangle to determine the area covered by one piece. But first, we have to make sure both dimensions are expressed in the same units. Since we calculated the area of the room in square feet, we'll do the same for a single piece of flooring. The length is already in feet, but the width is measured in inches, so we'll have to convert that to feet as well. We'll do that in a separate side calculation.
Because there are 12 inches in a foot, we know that the width of 7.25 inches is a portion or part of 1 foot. But how can we describe that part? Let's set it up as a fraction, with 7.25 inches as the numerator or part, and 12 inches as the denominator or whole. Now we can make this fraction equal to a second fraction with measurements expressed in feet. We'll put 1 foot in the denominator, since that's equivalent to the 12 inches on the left side of the equation, and the unknown part of the foot will be represented by x here in the numerator.
Since the right-hand side of the equation is x over 1, we can simplify that as just x. We can also simplify the left-hand side of the equation by dividing 7.25 by 12. That gives us an answer of 0.6. So our simplified equation is 0.6 equals x. That means the width of the vinyl plank flooring is 0.6 feet.
Now we can calculate the area of one piece of the flooring. We'll use the area formula for rectangles of length times width and substitute in the values of 4 feet and 0.6 feet. When multiplied together, we find that the area of each piece of the vinyl plank flooring is 2.4 square feet.
Now that we know how much area each piece will cover, we can divide the total area of the flooring required for the room by the area of each individual piece. This gives us 241 square feet divided by 2.4 square feet per piece, which results in 100.4 pieces.
Another example where builders had to know how to calculate the area of complex shapes is for the exterior siding of a house. Let's take a look at this end of the house. To determine the surface area that needed to be covered with the vinyl siding material that the homeowners chose, we can break the overall shape into some simpler areas. We can see that there's a rectangle here on the bottom and a triangle here on the top.
Let's determine the areas of these simple shapes, and then we can add them together afterwards. For the rectangle, the length is 25 feet and 6 inches, or 25.5 feet, and the width, or in this case height, is 8 feet. By multiplying these two dimensions, we find that the area of the rectangle is 204 square feet.
Now, to calculate the area of the triangular shape above, we'll use a different formula. For right-angled triangles, the formula is area equals 1/2 the base multiplied by the height. You can see where the right triangle is in this triangle. It's where the line measuring the height intersects with the base of the triangle. The base of the triangle measures 25.5 feet, the same as the length of the rectangle below. And the triangle's height is 11 feet. Substituting these values into the formula and multiplying 1/2 times 25.5 times 11, we get a value of 140.25 square feet.
When we add the area of the rectangular section to the area of the triangular section, we get a total area of 344.25 square feet of siding required for this end of the house. But there's one little detail that we haven't considered. Did you notice what it is? That's right. This section of the house, which is on the end of the garage, has 2 windows that aren't covered with the vinyl siding material.
The builders had to factor that into their calculation of the amount of siding required. Because each rectangular-shaped window is 4 feet wide and 4.5 feet in height, a simple area calculation reveals that they have an area of 18 square feet. Together, the 2 windows have a combined area of 36 square feet, which can be subtracted from the total area of vinyl siding needed to cover this section of the house's exterior. So, the actual surface area of siding required is 344.25 minus 36, or 308.25 square feet.
Much like the flooring installers do, the siding installers add an additional 10% to this figure to make sure they have more than enough material on hand. So, multiplying by the factor of 1.1 gives us a value of about 339 square feet of siding required. Just like with the flooring calculation, we can determine how many pieces of vinyl siding will be needed for the job. To do so, what do we need to know first? Exactly! We need to know the size of a single piece of siding material. For the vinyl siding used on this house, each piece measures 12 feet in length and 8 inches in width. Pause the video here to see if you can figure out how many pieces of siding would be needed for this end of the house, and then come back and check your calculation.
Alright, let's start by determining the area for a single piece of the vinyl siding. Because the shape is a rectangle, we can use the formula area equals length times width. The length is easy, that's 12 feet, but the width is 8 inches, so we need to convert that to feet also. 8 inches is a part of 12 inches, and is equivalent to what part of a foot? We'll use x to represent the unknown part of a foot we are solving for. Because the right-hand side of the equation is x over 1, or just x, we can simply divide 8 by 12 on the left-hand side to get 0.66. So, the width of a piece of the vinyl siding is 0.66 feet.
We can now enter 0.66 feet as the width and 12 feet as the length in our area formula and calculate the result to be 8 square feet. Each piece of vinyl siding covers 8 square feet of area. If we divide the total area to be covered, that's 339 square feet, by the area of each piece, 8 square feet, we find that about 42.4 pieces will be needed.
For a final example of how construction professionals use area calculation in their jobs, we'll go back inside the house and look at the kitchen island. Look at the complex shape of the countertop here. This unique 7-sided shape is not a regular polygon, since the sides are of different lengths. It's quite a complex shape. Because the cost of the quartz material used in the countertop is charged by the square foot, the builder needs to determine the total area of the countertop to know how much the supplier will charge for it.
In order to make this calculation, we'll break this complex shape into a combination of simpler ones. We'll start by drawing a line here from this outside corner to this inside corner to split the countertop into two sections. The section on the right is a trapezoid with 4 sides of different lengths. By drawing a line here that intersects the longest side at the right angle, we can create a simple rectangle and a right-angled triangle.
The remaining section on the left has 5 sides, but if we draw a line between these 2 points, we can create a right-angled triangle at the end and a trapezoid next to it here. By drawing lines from these corners of the trapezoid to intersect at right angles with the longest side, we can create a rectangle with a right-angled triangle on either side of it.
Now we have broken the complex shape of the island countertop into 2 rectangles and 4 triangles. That will make the job of calculating the total area much easier. What do we need next? That's right. We need to know the dimensions of these rectangles and triangles in order to calculate their areas. We'll use dimensions of inches for now and convert everything to square feet at the end of the process.
This side of the large rectangle is 51 inches. We'll call it the length. This side is 36 inches. We'll call that the width. Let's calculate its area by multiplying these 2 dimensions together. We find out that the large rectangle has an area of 1,836 square inches. Let's do the same type of calculation for the smaller rectangle. It measures 25 inches by 36 inches. So when we use the area formula, we determine that its area is 900 square inches, just about half the area of the large rectangle.
Now let's have a look at these 4 triangles. What's really interesting about them is that they are all identical triangles. Each one is a right-angled triangle with a base that is 15 inches wide and a height that is 36 inches. Using the formula for calculating the area of right-angled triangles, we can substitute these values in for the base and height. When we multiply 1/2 times 15 times 36, we get a result of 270 square inches.
We now know the areas of each of the simple shapes in our complex island countertop, so let's add them together to find out the total area. The large rectangle has an area of 1,836 square inches, which we'll add to the 900 square inches of the small rectangle to get 2,736 square inches.
Since the 4 triangles are identical, we'll just multiply the 270 square inch area of each one by 4 to find out their combined area. 270 times 4 equals 1,080, so that means together the 4 triangles have an area of 1,080 square inches. When we add that to the area of the 2 rectangles, we get a grand total of 3,816 square inches.
Because the cost of the quartz countertop material is charged by the square foot and not by the square inch, our final job is to determine what the area of the countertop is in square feet. Here's a quick way to do that. We can think of a square foot as measuring 1 foot by 1 foot. Because there's 12 inches in a foot, that square foot would measure 12 inches by 12 inches. And because 12 times 12 is 144, we know that there are 144 square inches in a square foot.
Now we can go back to the total area of the countertop in square inches and convert that to square feet. If we divide the 3,816 square inches by 144 square inches per square foot, we find out that the countertop has an area of 26.5 square feet. Now the builder can check the supplier's cost per square foot for the quartz material and find out how much the countertop will cost.
Today, we looked at 3 examples of how construction professionals use area calculations in their work. For interior flooring exterior siding, and countertops, the complex shapes that often occur can be broken down into simpler, more common shapes to make the calculation of their areas easier. This is very important for determining the amounts and costs of the
We also
materials
looked
needed.
at how we can divide large areas like flooring in rooms and siding on exterior walls by the area of an individual piece of flooring or siding to determine the number of pieces of the material that are required.
Can you think of any other examples of complex shapes that can be broken into simpler shapes? Or large areas that are covered with or composed of pieces with smaller areas in your home?